In this class, we'll learn how to solve simultaneous equations with one linear and one quadratic equation. X plus y plus 1 is 0. X squared plus y squared is 25. We use substitution from the linear equation. We know y is minus x minus 1. Let's substitute it in the quadratic equation. We get x squared plus minus x minus 1 squared equals 25. Open the brackets, we get x squared plus 2x plus 1. This is 2x squared plus 2x plus 1. It is equal to 25. Move 25 to the left side, we get 2x squared plus 2x minus 24 is 0. Divide 2 on both sides. We get x squared plus x minus 12 is 0. Factorize it. And we have x plus 4 times x minus 3 is 0. Therefore, x is 3 or minus 4. Substitute x back into y equals minus x minus 1. We get the solution as x equals 3 and y equals minus 4, or x equals minus 4 and y equals 3. Remember to write them in pairs so that the correct x matches the correct y. Two x plus 3y is 7. 3x squared equals 4 plus 4xy. From the linear equation, we get y is 7 minus 2x over 3. Let's substitute it in the quadratic equation. It becomes 3x squared equals 4 plus 4x times 7 minus 2x over 3. Multiply 3 on both sides. We get 9x squared equals 12 plus 28x minus 8x squared. This is 17x squared minus 28x minus 12. Factorize it. We have x minus 2 times 17x plus 6 is 0. Therefore, x is 2 or minus 6 over 17. Substitute x back into y equals 7 minus 2x over 3. We get the solution as x equals 2 and y equals 1, or x equals minus 6 over 17 and y equals 131 over 51. Sometimes we'll see problems involving the relationship of a line and a curve. We may use discriminant and quadratic inequalities to solve these problems. Find the set of values of k for which the line x plus y equals k doesn't intersect the curve x squared plus y squared equals 25. We can treat these two equations as simultaneous equations. If the line doesn't intersect the curve, then these simultaneous equations have no solutions. From x plus y equals k, we get y is k minus x. Substitute it in the curve equation, we get x squared plus k minus x squared is 25. It is x squared plus k squared minus 2kx plus x squared minus 25 is 0. Combine like terms, we get 2x squared minus 2kx plus k squared minus 25 is 0. This should have no solutions. Therefore, the discriminant del2 is negative. So 4k squared minus 4 times 2k squared minus 25 is less than 0. Take out 4, we get 4 times k squared minus 2 squared plus 50, which is equal to 4 times minus k squared plus 50. This is less than 0. Therefore, the answer is k less than minus 5 root 2, or k greater than 5 root 2. Let's look at the graph. We know the curve is a circle. The line is like this. Depending on the different value of k, the line moves in parallel. When k is less than minus 5 root 2, it's away from the circle. This is when del2 is negative. As k increases, it gets closer to the circle, until k is minus 5 root 2, when it becomes a tangent of the circle. This is when del2 is 0. When k keeps increasing, the line begins to have two intersections with the circle. This is when del2 is positive. When k is 5 root 2, the line becomes a tangent of the circle again, and del2 is 0 again. If k keeps increasing, the line has no intersection with the circle again. And del2 is negative again. In this class, we learned: use substitution to solve simultaneous equations involving one linear and one quadratic equation. Use discriminant to solve the relationship of a line and a curve problem.